In physics class, you learned that the slope of a position curve gives you the velocity of the object whose position is represented by that curve. In other words, if I have an object that's traveling according to this function, distance d from some point as a function of time is equal to time cubed. Okay, and that generates this purple graph right here. So I want to get the velocity of this object, how fast is it going, and that's going to be the slope of this green line, or at least this green line is an approximation of that slope, because this green line is drawn between two distinct points. But since this is a curve, I really just want the slope of the tangent line at this point right here. So I'm going to approximate this using a small change in t, delta t, and the corresponding change in d, delta d. So in this particular example, I've changed my t by 0.2 from t equals 2. This is where I want to calculate the actual velocity. And so I'm going to say, well, what happened between time equals 2 and time equals 2.2? Well, what happened was the object moved from a position of 8 to a position of 10.65, according to this function. And so the change in distance was 2.65 for the change in time of 0.2. And I do the calculation here and I get a slope of 13.24. But again, that's only an approximation. So I can get a better approximation by moving this point closer and closer. And so as I do that, you can see that my value of delta t is decreasing, and I'm getting a correspondingly decreasing value for delta d. So as I get closer and closer to time equals 2, and I'll stop right here, we see that my slope calculation is 12.06. If I move this value right to time equals 2, I have no change in time, no corresponding change in position. 0 over 0 gives me an undefined slope. Let's look at what happens from the other side. If I move my second point just a little bit to the left of t equals 2, or to the negative side, I have a change in time of negative 0.01 and a corresponding change in distance of negative 0.12. The slope calculation down here then gives me 11.94. So as I go back and forth between 1.99, 2, and 2.01, watch what happens here. At 1.99, my slope is 11.94. At x equals 2, my slope is undefined. And at x equals 2.01, my slope is 12.06. So it seems reasonable that the slope at that point should be 12, or could be 12 at least. Now the question is, why can't I calculate that? Okay, the graph itself has no holes or breaks in it. What does have a hole in it is the calculation for the slope. And so to actually calculate that value of exactly 12, we're going to use limits and approach time equals 2 from the left and approach time equals 2 from the right. A lot like what we were doing on the graph, but we'll get a lot closer than the 0.01 difference in time, and we'll be able to calculate that value of exactly 12.